Hello, everyone. How are you? I hope your projects are all going on well. Today, I'm going to share you my new work that is called Automated, Unsupervised, and Non-parameterized Inference of Data Patterns and Anomaly Detection. And I did this with all the professors as listed here, including Professor Lee, Professor McFlow, and also Professor Lamotte. So first of all, as we are discussing the tasks related to patterns, what are patterns and what are the anomalies? So data patterns are regular expressions that can describe the syntactic variations in the strings. For example, the pattern for a data column, as we have here, can describe it using the digits and the dashes. And what are the anomalies? So when we are talking about pattern anomalies, we do not adequately say that it is something violating the semantics, but it is a violation to the syntactics. So you can see it from here, and anomaly for date. What are the anomaly for date? So we still have the 4 digits, 2 digits, and 2 digits, but you can see it from the between each 2 tokens, there are no dash anymore. There's only a blank space. So all this kind of records cannot be matched into the previous pattern. That being said, it is the pattern anomalies. So how to detect pattern anomalies? Of course, because data is very important to software engineering and also machine learning, so many people have done this to detect the pattern anomalies to enhance the quality of their database. So regular expressions are one of the main way to match the pattern anomalies and to deflect them. So regular expressions can be written by users or automatically inferred. For example, we have the declarative tools such as TF-DV, DQ, and Scanner4C. The Scanner4C is not that declarative, but it requires the human labeling. However, there's a problem in this kind of tools that being said, we have to manually write the regular expression, which is very time-consuming. This is a very widely applicable problem to all the supervised methods. So to reduce this human labor, there are some people establishing the automatic tools such as Portersville, XSystem, /profile. Although they are really great, they are really fast and efficient in detecting the patterns. However, they sometimes require parameters such as frequency threshold or branch number. That being said, how many regular expressions are you expecting? Which is not so good for anomaly determination when you do not have adequate knowledge about your data. Let's say you are just a newcomer into this company and you do not understand the data at all. How can you use them? How can you design the frequency threshold? So these are the problems that Riolu is going to solve. So Riolu is actually this blue dog, which is my favorite Pokemon. So I named this tool after it. Riolu is the abbreviation for regular inferencer, non-parameterized learning with unclaimed data. I know it's a very long name, so let's just go with Riolu. And based on Microsoft's assumption, we are using this intuition that good patterns should make enough matches on the training set that's being set. We use a subset of the data to learn the regular expressions and see whether it is generalizable to the testing set. And our testing set is a whole column that being said we are extracting the regular expression and then do the matching to see whether this matching the coverage is adequate. So Riolu supports automatic pattern inference and also it is parameter free. Moreover, it is also suitable for data profiling, which is another very important task in the field of data engineering. Here we have this methodology overview. I'm not going to go into details of this, but if you are interested, maybe you can pause here and have a look. So basically, we have 5 steps in extracting the patterns, including column sampling, coverage rate estimation, template generation, pattern generation, and also pattern selection. So after these 5 steps, we can obtain the patterns that are healthy and suitable for both data profiling and data anomaly detection. So let's jump directly to the result of RealLu to see whether it is good or not. So we are comparing two versions of RealLu, that is older RealLu and guided RealLu. These two versions are different when they are doing the coverage rate estimation. So you can see some details from the last page if you are interested. And we are comparing this with Flash Profile, which is the previous state-of-the-art established by Microsoft. As you can see from here, the qualitative analysis guided RealLu has the best performance among all of these tools, but also older RealLu is outperforming the Flash Profile and dynamic Flash Profile. And also you can see from here the qualitative analysis to understand how are the qualitative differences between all the tools. For example, from the state code, usually state code should only accept two digits, such as ON as Ontario and QC as Quebec. But for Flash Profile, because of their learning schema, they accept all the letters regardless of their upper letter or lower letter, which is very inaccurate and will accept a lot of false negatives. When we are using the dynamic threshold, it has eliminated a lot of false negatives. And when we are turning to both RealLu, it can provide more accurate results. And here we also did another test with the data profiling task. So we use the data set provided by Flash Profile. So you can see from here, we have reached a very, very high F1 score that is 97.07%. And also the false positive rate and the false negative rate false negative rate are very low, so that it is in a good performance, and it is even better than the previous data. That being said, the previous data is Flash Profile, so it has a higher F1 score, saying that it is efficient in both data profiling and data anomaly detection. So that's all of today. We don't have a lot of time, but let's hope that it got published so that I can have more videos introducing how RealLu works and let more people use this tool to benefit their data quality. Thank you, everyone.